commuting to work, heading to the gym, or maybe taking a short focused break between study sessions. Perfect. Because you are joining us for a deep dive. We're tackling a topic that fundamentally challenges the way traditional costing methods measure and, well, see profit. Throughput accounting. Now, this conceptual clarity is particularly crucial if you're currently tackling performance management, where you're asked to apply these concepts to real managerial decisions. We know that diving into a new cost method can often feel like wading through complex formula sheets, maybe a bit daunting. But our mission today is pure conceptual mastery. We want you to understand the intrinsic logic behind throughput accounting, or TA, so that when you see the formulas later, they don't feel like arbitrary steps, but more like logical consequences of modern factory dynamics.
That's absolutely the core of it. Yeah. We recognize that traditional costing methods, which, rely heavily on maximizing contribution across a broad range of variable costs, they can sometimes lead management astray, especially when dealing with a modern, highly automated, and frankly fast-moving factory. Throughput accounting is explicitly designed to give management a far more realistic, relevant, and actionable lens, especially for those urgent short-term production decisions. So our deep dive today will focus on explaining a pretty revolutionary idea. Why, in this world of high automation and just-in-time production, the JIT environment we hear so much about, why raw materials are often the only true short-run variable cost that matters. And critically, we'll explore how every single resource allocation decision must then be geared towards leveraging the single most limited resource in the entire system. That's the bottleneck, right? Leveraging that for maximum financial gain. This isn't just about accounting numbers. It's really about optimizing the flow of cash through the entire business.
Okay, let's unpack this concept of TA as an evolution. Because like you said, it didn't just appear out of nowhere. It built upon existing managerial tools. So we probably need to start with the foundation. Key factor analysis, or KFA. Sometimes called limiting factor analysis, right?
That's exactly the right historical starting point. KFA provides that conceptual structure. It's the tool managers use to address the classic scenario where a business has multiple profitable products, but they're all competing fiercely for a single, finite, scarce resource. Perhaps it's a specific, highly skilled technician's time, or maybe the limited available hours on a really specialized piece of machinery. You know the type.
And the standard approach in KFA, it seems very logical, right? The priority is set by efficiency. You calculate the conventional product contribution, that's sales revenue, minus all the variable costs. And then you rank the products based on how much contribution they manage to earn for every unit of that limited resource they consume. So if specialized machine hours are scarce, the priority goes to the product that earns the most contribution per machine hour. Seems rational.
It is entirely rational within its own framework, absolutely. And it's important we define our term for that traditional framework clearly. The term contribution in conventional KFA means sales revenue minus all variable costs. Historically and traditionally, this bundle included material costs, direct labor costs paid to workers, and any variable overheads. Things like maybe specific utilities or consumables that scale directly with production volume. The central assumption was simple. If you manufactured one more unit, all three of those cost elements increased proportionally.
Right, that model of cost behavior where labor and overheads are truly unit variable makes perfect sense in certain settings, maybe more traditional factory setups. Like if I hire a large group of temporary workers by the hour and can easily let them go or hire more, okay, that labor feels variable. If my machinery uses significant power that's billed strictly based on consumption per unit run, yeah, that overhead seems variable too. But this brings us to the conceptual jump, doesn't it? The pivot point where throughput accounting steps in and fundamentally breaks away from KFA. Why, in a modern manufacturing environment, do we need to fundamentally amend that sensible and rational KFA approach? What changed? What broke the model?
Well, what broke the model was the fundamental shift in manufacturing philosophy and technology. This really took place primarily starting in the 1980s and onwards. The basic assumptions that labor and overheads behave variably have been fundamentally altered by two primary forces. One, the adoption of just-in-time, JIT, and lean methodologies. And two, the massive increase in automation and technology on the production line itself.
Okay, let's delve into that JIT influence first. What does a modern JIT-style factory actually look like that changes our cost behavior calculations so drastically?
Well, a JIT environment is often characterized by three things that really shatter that old cost model. First, a high level of automation. Production is heavily machine-driven. When these sophisticated machines are running, the cost of operating them, the depreciation, the scheduled maintenance, the cooling systems, even the baseline electricity used to run the facility, is largely fixed in the short term. Whether the machine processes 100 units or 1,000 units this hour, those base capacity costs are incurred regardless. Second, labor contracts have changed quite dramatically. We've generally moved away from massive pools of easily scalable, low-skilled, hourly paid labor. The modern factory workforce tends to be highly skilled. Think robotics programmers, maintenance technicians, quality control experts, and they're often permanent salaried employees. So direct labor cost, in the context of a short-term managerial decision like, say, whether to accept a rush order today, it behaves entirely like a fixed capacity cost. You pay their salary simply to ensure the factory has the skilled human capacity available to run. It's not a cost that increases reliably with the very next unit produced.
Wow, that is a massive conceptual shift right there. So if the factory is heavily automated and the expert labor is salaried, we're essentially forced to acknowledge that most of our traditional variable costs are actually fixed capacity costs, at least in the short term. The cost of maintaining the capacity, the expensive machine, the salaried labor, the basic utilities for the building, it's locked in for the operating period.
Precisely. And this is the radical core belief of throughput accounting. Since labor and most non-material overheads are fixed capacity costs in the short run, often committed costs you can't change quickly, they should be completely ignored when making a short-term production decision. They simply don't influence the incremental profitability of running one more unit. So if we must decide which product maximizes profitability over the next week or month, the only cost that truly and directly varies with every single unit produced is the cost of the raw material itself. If you don't make the unit, you don't buy the material. Simple as that.
That distinction, that's the key intellectual breakthrough of TA, isn't it? Material being the only true variable cost shifts the entire focus of management. Instead of maybe obsessing over fixed cost cutting, which is often slow and maybe impossible in the short term, the attention turns to maximizing the revenue generated above that material cost and doing it efficiently.
Okay, to really crystallize this idea, let's explicitly articulate the two main, almost revolutionary concepts that form the backbone of throughput accounting. The first, as we've just established, is the cost behavior premise. In the short run, virtually all operational factory costs, that's direct labor, variable overheads, they're fixed. They're collectively locked into a capacity pool, except for the cost of the raw materials.
Okay, that's number one. And the second concept flows directly from that JIT philosophy, right? And it has huge implications for how we view wealth creation in the business.
Yes, exactly. The second concept is the inventory premise. In a JIT or lean environment, the business must constantly attempt to minimize or, ideally, eliminate inventory entirely. Large inventory holdings are seen as waste. The business should really only produce what can be sold almost immediately.
Now, this second premise, that leads us into a pretty deep conflict with traditional absorption costing methods. Let's explore the profound implications of this cost behavior premise further. If TA assumes that labor, variable overheads, and fixed overheads are all just lumped together into what we define as total factory cost, how does that actually help management?
It helps them by dramatically simplifying the decision-making process. I mean, think of the time saved. Management no longer has to engage in these complex, often arbitrary debates like, is this portion of labor truly semi-variable? Should the electricity bill be split 60-40 between fixed capacity and unit variable? TA just cuts through all that noise. It provides a clean, simple, operational truth. Everything necessary to run the factory labor, variable overheads, fixed overheads is the total factory cost, or TFC. And it's fixed capacity in the short term. The material input is the only incremental variable element relevant for those immediate production ranking decisions.
So we've essentially fixed the capacity costs in our minds for short-term decisions, and we've isolated the truly variable cost, which is just material. Now let's look at the financial reporting implications, specifically on the balance sheet, because this is where TA offers its most potent critique of traditional costing, how we value inventory, especially work in progress, or WIP.
Yes, this is perhaps the most critical insight for anyone studying management accounting. It really challenges conventional wisdom. If we accept the TA premise, then inventory must only be valued at its material cost. Nothing else. Full stop.
Okay, why is that such a stark departure? And why is it necessary from a TA perspective to ignore labor and overheads in inventory valuation?
Because valuing inventory higher by adding absorbed labor and overheads, as absorption costing does, creates what we call a perverse incentive. It encourages bad behavior. Under absorption costing, think about it. If a manager produces more inventory than is needed right at the end of a reporting period, that inventory sitting on the shelf absorbs a larger slice of the fixed overheads for accounting purposes. This reduces the amount of fixed overhead charged directly to the profit and loss statement as cost of goods sold for the units that were actually sold. And the result? Reported profit magically goes up, even if the excess inventory is just waste that might never be sold or sold at a discount later.
That is powerful. So management is basically incentivized to overproduce just to boost the paper profits reported for that period, leading to these large, wasteful stock levels that completely violate the entire JIT philosophy of minimizing waste.
Exactly. TA eliminates that incentive completely. By valuing inventory only at material cost, there is no fixed cost absorption mechanism to manipulate profit figures.
Hmm.
The only true economic value added to that specific piece of inventory is the material input. All the labor and overhead costs are incurred whether or not that piece of WIP is finished and sold. TA forces management to focus on flow and sales, not on stocking the shelves for purely accounting purposes.
Okay, so the overarching goal shifts entirely. We are no longer trying to absorb all costs into inventory. The mantra of TA becomes something like maximize the immediate cash generated, net of materials, and do it as quickly as possible by leveraging the system's most limited resource. This immediate cash generation is what TA calls throughput.
Precisely. Maximizing that flow is the sole focus. TA aligns management with the objective of turning raw materials into immediate cash at the fastest possible rate, specifically relative to the one constraint, the one bottleneck that dictates the speed of the entire system.
Right. Now that the core philosophy is firmly established, materials are the only variable, inventory should be minimized, we need to pin down the precise terminology, the terms needed to actually apply TA logic. If the factory floor is the stage, we need the program guide, so to speak. Let's make sure we clearly define the three central characters in this TA drama.
Sounds good. Let's start with the hero of our story, throughput itself.
Okay, definition A, throughput. If we're explaining this to a manager who has only ever used conventional contribution, how do we define throughput conceptually? Simply.
Conceptually, throughput is defined simply as sales revenue minus the material cost. That's it. It is the immediate cash income generated by selling one unit, after removing the only truly incremental variable cost incurred to make that unit, which is the raw material itself. Think of it as the money flowing through the factory from sales, after paying for the stuff it's made of. We want to maximize the velocity and the volume of this flow. In a traditional sense, you could almost think of it as material contribution, though TA gives it the specific name throughput.
Okay, simple enough. Sales less materials. Got it. Now, on to all the other costs we just decided to ignore when calculating that contribution.
Right, those costs we bundle together.
Definition B, total factory costs, TFC. Since we've decided labor and overheads are fixed in the short run, how do we treat them collectively?
TFC is the collective lump sum of all other production costs except for the materials. And just to be crystal clear, this includes everything: direct labor, all variable overheads, as traditionally defined, and all fixed overheads, all lumped together. Philosophically, TFC represents the fixed operating expense, the short-run cost of just maintaining the factory's capacity and capability. If the factory runs for 1 hour, TFC covers the salaries, the rent, the scheduled machine maintenance, the basic utilities you pay just to keep the lights on and the machines ready to go. It's the cost of being open for business.
Right, so TFC is the fixed operating expense that must be recovered by the cumulative throughput generated over the period. We need enough total throughput to cover that big lump sum. And finally, the element that controls the entire rate of recovery, the speed limit.
Yeah, exactly. Definition C, the bottleneck resource. This is arguably the single most crucial concept in the entire TA system. It's deeply rooted in the theory of constraints, or TOC. The bottleneck is the critical choke point in the entire sequence of operations. It is the machine, the specific process, or maybe even a department or stage that is slowest. And because it's the slowest, it physically dictates the maximum overall rate of production for the entire business. Everything has to wait for it.
Okay, let's use that Yamco example from the source text again to make this tangible, because understanding the bottleneck really is everything, isn't it? Yamco processes sheet metal through 3 processes: pressing, stretching, and rolling. How do we pinpoint which process is the bottleneck there?
We look at capacity relative to demand for each process. Suppose Yamco has 3 machines: machine P for pressing, machine S for stretching, and machine R for rolling. Let's say, based on current product demand, the business needs to process a total of, say, 900,000 meters of metal this period. We then calculate the effective capacity of each machine. Maybe machine S stretching and machine R rolling are quite fast. Perhaps they can handle 1 million meters and 1,200,000 meters respectively over the period's available operating hours. They clearly have surplus capacity compared to the 900,000 needed. But machine P, the pressing machine, maybe due to its specialized nature or it's just inherently slower, It can only handle a total capacity of 850,000 meters of metal in the same period.
Ah, okay, there's the problem right there. Demand is 900,000 meters, but the pressing capacity is only 850,000 meters. So even though stretching and rolling could handle the full 900,000, the factory's overall maximum output is limited to 850,000 meters because that's all the pressing machine can physically push through. Pressing is the bottleneck.
Precisely. The pressing machine, despite being just one step in the chain, sets the absolute speed limit for the entire factory's output. And the core conceptual insight here is profound. Time lost at the bottleneck is lost forever for the entire system. If machine P is down for 5 minutes, the entire factory's ability to generate cash flow literally stops for those 5 minutes. However, if machine S or R, the non-bottleneck processes, are down for 5 minutes, well, the overall output might not change at all. They might have a small buffer of work built up, or they can simply catch up later because they have spare capacity. It doesn't impact the final output rate set by P.
This is where we really start to see the divergence from conventional thinking, isn't it? In a traditional factory, if the operator of machine R, the fast-rolling machine, speeds up and runs at 100% efficiency, they're often praised, maybe even get a bonus. But in the TA world, if machine R processes material faster than the bottleneck, machine P can actually handle it. What happens then?
You simply create a massive pile of work-in-progress inventory sitting right in front of the bottleneck, machine P. That pile ties up cash and material costs, it takes up valuable floor space, it complicates management, and crucially, it does all this without generating a single extra dollar of cash throughput for the business, because the output rate is still capped by machine P. TA teaches that the only effective way to increase profitability is to manage the flow of the entire system based on its weakest link, the bottleneck. All other resources, human and mechanical, must be subservient to optimizing the flow through that bottleneck. Nothing else ultimately matters for system output.
Okay, so we've done the groundwork. We have isolated the only true variable cost, which is materials, and we have identified the only true capacity constraint, the bottleneck. Since the bottleneck controls the flow of cash, or throughput, management's entire responsibility shifts. It becomes about prioritizing products that maximize throughput for every single unit of time the bottleneck spends working on them. Is that right?
Exactly. That's the core decision rule. We can no longer rely on just looking at total throughput per product or even conventional contribution per product, because we need to normalize that return against the scarce resource, the bottleneck time. We need specific tools to measure the efficiency of how we use that bottleneck's precious time. We generally utilize 3 key metrics for this purpose. The first, and probably the most important for prioritization, is Tool 1, return per factory hour. Sometimes you'll see it called return per bottleneck hour. Same thing.
Okay, how does the logic of this metric work? In plain language, what's telling us?
The logic is actually quite simple. We take the total throughput earned by selling 1 unit of a product. Remember, that's sales revenue minus material cost. And we divide that throughput figure by the total time that product requires on the bottleneck resource. Not total factory time, just bottleneck time. This calculation tells management the exact amount of cash, net of materials, earned for each hour that the bottleneck is tied up working on that specific product. It's purely an efficiency metric of cash generation relative to the constraint. Now, the crucial differentiation here from conventional KFA is important. KFA maximized contribution per limiting factor hour, which included assumptions about labor and variable overheads being variable. TA maximizes throughput per bottleneck hour, isolating the metric purely to the cash inflow generated relative to the time spent on the choke point. This provides a much cleaner measure for short-term decisions because, as we've said, the labor and most other overhead costs are incurred regardless of which product runs.
That makes perfect sense. We're focusing on maximizing what we can change in the short term, which products run on the bottleneck, while holding constant what we can't change quickly, the fixed factory costs, the TFC. Okay, so we know how much cash throughput each product generates per bottleneck hour. Now we need to compare that return to something, like the cost of keeping the bottleneck running.
Precisely. We need context. That brings us to Tool 2, cost per factor hour. This metric essentially quantifies the price of having that bottleneck capacity available in the first place. The calculation is straightforward. You take the total fixed cost of running the factory, our previously defined total factory cost, TFC, and you divide that TFC by the total available operating hours on the key resource, the bottleneck, during that period. This gives us the average cost or price of making that specific bottleneck resource available for 1 single hour.
Okay, let's use an example. If we take the TFC, maybe it's, say, $360,000 for the month, and we know that the bottleneck machine has 48,000 total available hours this month, then the cost per factory hour is $360,000 divided by 48,000 hours, which is $7.50 per hour. What is the significance of that $7.50 figure? What does it represent?
That $7.50 is the benchmark. It's the hurdle rate, if you like. It represents the average hourly price we pay, purely in fixed capacity costs, labor, overheads, etc., just to keep the factory doors open and that bottleneck machine ready and running for 1 hour. Therefore, any product we decide to prioritize on that bottleneck must, at the very minimum, generate more than $7.50 of throughput per hour, our first metric, just to cover its proportionate share of the fixed capacity cost it's consuming. If it doesn't generate more than $7.50 per hour, we are effectively operating at a loss on an operational flow basis every hour we run that product on the bottleneck.
Right. So that relationship between the return per hour and the cost per hour needs to be favorable. And that comparison is quantified in the final, most important measure for high-level decision-making, isn't it?
That is tool 3, the Throughput Accounting TA ratio. The TA ratio is simply a direct comparison. It's the return per factory hour, the cash generated per bottleneck hour, divided by the cost per factory hour, the capacity cost per bottleneck hour. You can think of it as the pure efficiency index of our products relative to our fixed costs, specifically focus on the bottleneck constraint. The key takeaway here, the absolute decision rule is this. The TA ratio must be greater than 1 for a product to be considered operationally viable in the short term.
Let's delve deeper into what that ratio is actually telling us. What if the ratio is, say, 0.8? What does that mean practically?
If the TA ratio is 0.8, it means that for every $1 of fixed factory expense allocated to running the bottleneck for an hour, that product only generates $0 of cash throughput net of materials during that hour. You are literally losing money on the operational activity itself. The product is acting as a factory capacity drain when run on the bottleneck. Management must immediately review, maybe re-engineer the product or process, or potentially stop production altogether for products with a ratio less than 1. Because they are consuming precious bottleneck capacity that could be better used by products generating a ratio greater than 1.
Okay. Conversely, if a product has a TA ratio of, say, 1.5, then we're generating $1.50 of cash throughput for every $1 of fixed capacity cost absorbed by that bottleneck hour. That sounds like a pretty efficient use of the scarce resource.
Precisely. That's a healthy product from a TA perspective. And when prioritizing production across multiple viable products, all with ratios 1, priority is given, first and foremost, to the products that generate the highest TA ratios. This metric cuts through all the noise of, labor variability debates or complex overhead allocations. It directs management instantly and clearly to the most efficient and profitable use of the single critical resource that limits the entire system's performance.
This conceptual focus is incredibly powerful, isn't it? It transforms the costing discussion from maybe academic theory into a really practical, real-world mechanism for managerial efficiency. The strategic application of TA seems to be where it truly shines, aligning management's attention directly to where it can have the maximum impact.
Absolutely. TA forces management to focus, almost like a laser beam, directly on the constraint. The philosophy is fundamentally linked to the theory of constraints, TOC, as we mentioned. If you can fix, improve, or just better manage the bottleneck, for instance, by ensuring it has zero idle time, optimizing material flow to it, maybe investing in parallel capacity for just that step, you instantly increase the overall capacity of the entire factory, not just that one step. This, in turn, increases total potential throughput and maximizes overall cash generation for the business.
And the flip side of that is the painful truth we have to accept under TA. If you invest significant capital or managerial time in improving a non-bottleneck process, say making machine R, the fast roller, 50% faster, the overall system speed remains completely unchanged because the entire system is still limited by the speed of machine P, the press.
Exactly. That investment of time or money is functionally wasted, at least in the short term, from a system perspective. TA provides a powerful analytical tool to prove this. It essentially tells management, look, don't bother improving what is already efficient enough. Focus only on the system's weakest link.
Yeah.
This enforces an incredibly disciplined approach to resource allocation and process improvement efforts.
This deep focus immediately links TA to those broader strategic movements like lean manufacturing and just-in-time production. How does that connection work?
They are inextricably linked, really. TA reinforces the philosophical underpinnings of lean production in several key ways. For instance, that inventory premise we discussed, valuing inventory only at material cost, is a powerful behavioral mechanism. It dramatically reduces the accounting incentive for managers to hoard inventory or overproduce just to make their period's profit numbers look good.
Think about the culture change required. In a traditional plant using absorption costing, managers are often rewarded for maximizing the utilization of their specific machines or their department, keeping their people and equipment busy, regardless of whether the rest of the system needs that output right now. This local optimum thinking is precisely what creates those massive buffers of unwanted inventory between processes, which TA views as pure waste.
So TA teaches us to optimize for the system flow, not just local utilization rates, which means we should strategically run non-bottleneck processes at a deliberately slower pace, a pace dictated by the bottleneck, specifically to prevent that inventory buildup. That must be counterintuitive for most operators and managers used to the old way. It absolutely is, and it requires careful cultural management and clear communication. It means sometimes telling a perfectly capable non-bottleneck operator to wait, to stand down, or to intentionally slow their machine down. Because if that operator makes product X faster than the bottleneck machine P can actually process it, they are not adding value to the system. They are actively creating waste upstream. TA provides the financial justification, the rationale for this counterintuitive but system-optimizing strategy.
Okay, to bring this all together and make it really concrete, let's revisit that example of PF leg mentioned in the sources, just to show how TA can actually change real ranking decisions compared to conventional KFA.
Yeah, this example is perfect for illustrating the practical power of TA. Imagine Pi SAE manufactures two products. Let's call them Product A and Product B. Both products need time on the same bottleneck machine to be completed. They're competing for that scarce resource. Now, under the conventional KFA approach, management would calculate the contribution per hour on the bottleneck. Remember, conventional contribution is sales minus materials, labor, and variable overheads. Let's suppose product B shows a slightly higher conventional contribution per bottleneck hour than product A. Following KFA logic, management would traditionally prioritize product B. Why? Because conventional costing assumed B was better at covering all its individual variable costs per hour of constraint time.
Okay, so traditional view says prioritize B, but the moment we apply the throughput accounting approach, the picture changes, potentially quite dramatically.
Yes, potentially. Because now we ignore the labor and variable overheads in the calculation. Why? Because they are short-run fixed costs, part of TFC. We now focus purely on throughput, which is just revenue minus material cost, per bottleneck hour. So let's hypothesize what might be happening with Pi PLC. Product A might have required slightly more time on the bottleneck machine per unit than Product B did. KFA penalized it for this. But crucially, let's say Product A's raw material costs are dramatically lower. Perhaps it uses cheap plastic, whereas Product B uses expensive titanium. Product B, while quick to process on the bottleneck, uses extremely costly materials. See, the conventional KA method penalized Product A for its potentially higher labor usage or longer machine time, which TA ignores as fixed costs. But the TA calculation throughput per bottleneck hour reveals something different. Because Product A's material costs are so low, it generates a far greater cash margin throughput for every hour the bottleneck works on it compared to Product B. Even if it takes slightly longer, the cash generated per hour might be much higher.
So the result could be that Product A's TA ratio might be, say, 1.5, while Product B's, despite looking good under KFA, might only have a TA ratio of 1.1.
Exactly. This difference fundamentally changes the ranking and the optimal production plan. TA instructs management to prioritize Product A first, filling the bottleneck capacity with the product that most efficiently turns the fixed capacity cost into actual cash flow. Product B, despite its possibly higher conventional contribution, is revealed to be less efficient at leveraging the constraint from a pure cash generation perspective. This TA-driven ranking provides the better short-term profitability guide by focusing relentlessly on the only costs that are truly variable and relevant to the immediate decision: the materials and how effectively we turn them into cash using our most limited resource.
So the overriding summary of TA's strategic importance is really that it enforces a disciplined, holistic view of the entire production flow. It aligns managerial incentives directly with the system's constraints and the ultimate goal of generating cash quickly. It really moves us from managing costs locally to managing flow globally across the system.
Absolutely. That's the shift in mindset. The moment management truly understands and identifies the bottleneck, they know precisely where to focus all future capital investment, all process improvement efforts, and all operational monitoring. Investing significantly outside the bottleneck is only acceptable if it directly supports the bottleneck. For example, improving quality control before the bottleneck to ensure zero defective material ever reaches it and wastes its precious time. But simply improving non-bottleneck speed and isolation. TA teaches that just creates idle time downstream or inventory buildup upstream. Cash flow, driven by bottleneck throughput, is king. #outro. Well, we've taken quite a comprehensive deep dive today into throughput accounting, a really powerful and arguably more modern method for short-term decision-making in many environments. We established that its power lies in two clear JIT-influenced principles. First, that material is often the only truly variable cost in the short term, and second, that all profit must be maximized relative to the bottleneck resource, the system's constraint. That's right. And this approach is quantified using tools like the return per factory hour and, crucially, the TA ratio. That ratio must always exceed 1 for the operational viability of a product run on the bottleneck. It fundamentally shifts the entire operational focus away from maximizing local cost reduction or local efficiencies, towards maximizing the efficiency and flow of the single most constrained resource, the bottleneck itself.
Now, before we wrap up, let's just circle back briefly to the strategic and maybe cultural implications of TA. If the primary goal is maximizing throughput through the constraint, what kind of managerial systems and maybe employee incentives would we need to put in place to ensure this actually works effectively on the factory floor? Because it sounds like it could cause some friction.
Oh, it absolutely can cause friction. Think about that cultural point we touched on. As we discussed, a machine operator at a non-bottleneck station is explicitly asked under TA principles to not run at full speed if it means overwhelming the downstream bottleneck. That goes completely against generations of factory culture that rewards high individual or machine utilization. Keep busy. So, to achieve true goal congruence, getting everyone pulling in the same direction, we would need to design incentives very differently. Incentives that reward that non-bottleneck operator not for their own machine's efficiency report, but for the total output and throughput of the entire factory system. This might mean tying bonuses or performance metrics, not to local efficiency reports, but to things like how well they contribute to the bottleneck's sustained operation. Did they ensure perfect quality input so the bottleneck never processed a defect? Did they perform quick changeovers on their own machine to ensure the bottleneck was never starved of material? The challenge is designing a system where everyone understands and is financially incentivized to remember that the system is only as strong and fast as its slowest link. Their job is to support that link.
That challenge of aligning individual performance metrics with overall system performance, that sounds like it's often the final complex frontier in making throughput accounting truly effective in the real world. Mastery of TA doesn't just mean solving the calculation on an exam paper, it means solving the managerial flow and incentive challenge within the organization.
And that's throughput accounting, a powerful and, I think, essential way to see what really drives profit in a modern, lean business environment. If you like this comprehensive study companion, don't forget to subscribe to the SmartPass YouTube channel for more ACCA performance management audio lessons designed to fit into your day anytime, anywhere.